Imagine this. You just finished your lesson on percents and you had thought you had covered your basis. You thought you had covered and did a variety of different problems to show students how to calculate percents of various whole values, find 60% of this or 35% of this. And then now it's time for kids to work. So you're circulating and a kid puts up their hand and they're saying, how do I use the percent button on my calculator again? And you're like, you're thinking to yourself, like, I purposely did not show them how to push that button on their calculator because I know it doesn't add value. It doesn't add thinking into what they're doing. Yet the students are trying to do that, use that button on their calculator. In this video, what we're going to do is we're going to talk about how to get your students to think more deeply about percent. We want them to be fluent working with percents as ratios, as proportions. We're going to talk all about that. We're going to give you 2 or 3 different lessons to use in your classroom. Hey there, Math Moment Makers. John here from Make Math Moments. And if you have not yet subscribed to this YouTube channel, do that, please, as we are putting out videos every single week on how to help you in the classroom, how to create deep thinkers, how to create sense making with your students. In this particular video about how to teach percent, how to teach working with percent and solving problems using percents as a ratio, as a proportion, we're going to be talking all about that. I want to give you 3 different lessons to use in your classroom to do that, and a model that helps with that deep sense making and build fluency with your students. That's what we're after. We're after how do I build fluency so that we are flexible, so that we are accurate. That's what we want to do here in this particular video. When we teach percent, we teach it through problem-based lessons, and I want to show you 2 problem-based lessons you can use in your class. But before we do that, I want to make sure that we talk about the model used, because if you understand the model and how to use it, you're going to be in a great place to teach through a problem-based lesson with your students. Because as you know, if you've been watching this YouTube channel and listening to our podcasts or checking out our website, you know that we come from a place of conceptual understanding and allowing students to showcase their thinking and model their thinking, and then we can talk about strategies. And we want that to happen first instead of us directing how to happen. So in the intro to this lesson, I talked about my examples and how do I cover my bases. What we want to do is put students in positions to show some thinking, and then we can talk about strategies and how it connects to their thinking. But before you can do that, like before you can be a successful teacher teaching through these problem-based lessons, you do have to understand the math behind it or the models behind what we're working with. So what we're going to do is, instead of teaching through a problem-based lesson right off the bat, in this video, I'm going to show you how to use a model. And what I'm going to do is I'm going to pull up, you can see right behind me on my screen, I got my number line. That's the model I want to use. This is the model we've used in the past, in our past videos, to solve equations, like 1-step, 2-step equations, linear equations. We solve proportions and use it for ratios. We use this model quite frequently because it has legs, right? This model is very powerful. It stretches from younger grades all the way up into the higher grades. So we use this as consistently as possible, and then students become comfortable with using the number line when we think additively or multiplicatively. So we're going to talk about that and use this model to solve some problems. But I'm going to bring across an activity from Desmos. And I used this one recently with my students because it has a great kind of prompt to get kids to think first about what's happening here. So I'm going to kind of overlay here, and I'll show you what activity this was from in just a moment. But think about it like this. In this image right here, there's 2 machines, and the 20 is on a conveyor belt, and the 20 is going to move across the conveyor belt. It's going to go through the machine. And first, it's going to go through machine number 1, which is going to increase that number by 50%. And then it's going to decrease that number, that output, by 50%. And the question we want to know is what number comes out the other side? And a lot of students are tempted to think 20 is going to come out the other side. If I'm going to increase by 50% and I'm going to decrease by 50%, isn't that just give me back the same number? We want to explore this here with us. And so when I pose this to my students, I let them tackle this and show what their thinking is. And I encourage your students to model this with pictures or draw a number line, or draw a table, or all of these models that we've been using on a regular basis. We encourage them to use every time we get a new type of problem. So I just want to model what some of my students have done in the past according to a number line. This is what we want to get you comfortable with, using a number line to solve these types of problems. And then you can see that it's very flexible. And that's part of being fluent in mathematics and in certain number sense concepts. Is in order to be fluent, we need to be able to be flexible. We want to be able to be accurate. We want to be able to be efficient. And so a number line can help us do that. Let me show you what some of my students have done in the past with a number line, because it allows you to do all of those things. Where in my past self, I might have said, you know what, this is before the number line, is like, oh, hey, we're using percent, so I'm going to take 20. Oh, we're going to multiply, because we're going to multiply it by 50% to find out what 50% of 20 is first. And so you tell kids to turn that into a decimal, and you then multiply by the decimal version of 50%. Now, some students might remember this. Oh, I get 10 out of this, and I can calculate. Like that would be my old self to say, hey, just do these steps, and I can get an answer here. And I can add 50% to that. The problem with that is it doesn't allow us to be flexible. Some students are thinking it's just a set of rules, and I have to try to figure out, well, what happens if I change the scenario? How do I solve it then? That's the flexibility. That's the fluency part. So what we're going to do is we're going to model this on a number line and think about what this could look like. And so a lot of the times with my students, we talk about, okay, well, let's put 0 on the number line. Like, let me mark here, this is 0. And let's say if I have 0% of 20, let's put 0% up here. And if I had 0% of 20, how much is that? Well, that's 0. Great, awesome. Let me put 100% over here. If I had 100% of 20, how much would I have? And kids naturally will say, well, I got 20, that's 100%. And then I say, well, is there any really nice numbers I could put on the number line? Like give me a peg. I call them, we call them pegged or unit numbers here. Can I put on here that's real easy to think about? Students often say, well, we can put 50% on there. Sure, let's put 50% on there. And then we say, where does it go? And we can place that pretty straightforward. Half is 50%. So we got a halving happening here. And what number goes right here? It's very clear to our students right here. It should be a 10, right? There should be a 10. And that's a halving here. If I have a halving here, I have a halving down here. Or if I have a fraction of this, I have half of that, I get 10. So that's easy to place. And I said, well, was there any other easy to place numbers here along this? Like we could, some students might say, well, I could do 25% now. Like, even though we've got what 50% of 20 is right here, which is 10, we're going to increase it by 50% in a moment. But get our students fluent, get our students flexible with the number line. Hey, if I want 25%, that might be an easy pegged number to think about as well. Hey, I can put 25%. Well, that's half of 50%, so that must be 5. And then if I had, well, what's another one? Oh, another 75% might be a nice number here. And okay, well, that's, again, well, look, every 25%, I've had students say that, like, look, every 25% now is 5 more. So what's 5 more than this? This is 15. You can clearly see 5, 10, 15, 20. We're getting comfortable with how the numbers scale along the number line. And so if I had to increase, 20 by 50%, I could take 20. I'm going to increase it by the 50%, which is 10, and I get 30. So then now we have 30 that comes out of this machine and it goes into this machine. And it's going to decrease that 30 by 50%. And so students have in the past, say, drawn another number line, and we could set that up and go, hey, I got 0%, that's 0. If I have 100% now over here, that's now 30. And so where does 50% lie now? 50%. And now it's 50% of 30. Oh, well, that's a halving. So here was a halving, and I've got 15. So now I'm going to decrease my number by 15. And so I'm going to take 30, and I'm going to subtract 15, and I get 15 back. So 20 went in, it increased by 50%, and then it decreased by 50%, and I get 15 out. So I don't get 20 back. I actually get less. So the important part is using the model. That's the flexibility. So the nice thing about this Desmos activity, let me zoom out here for you, that you can see that this is challenge 1 in a Desmos activity. Now, if I went to challenge 2, this one's a nice one. I want to show you how it is really nice to be flexible with this model. And now it says I take 60, 60 is going to go in, it's going to increase it by some percentage, and I would get 72. Okay, so it's going to go, 60 is going to go in, and we're going to increase it by some percentage, and we get 72. So students will naturally start to go, okay, well, we've done this in the past. Well, 0% of 60, so I've increased it by 0%, it would increase it by 0. Now, if I increase it by 100%, that should increase it by 60, right? So I'm going to take 60. If I increase it by 100%, I get a 60. So I'm trying to increase it by some percent. I need 72. 72 is up here on the number line. Let's put 72 right here. I don't know what percent this is right here. But here's where our flexibility comes in. Kids will start to peg numbers along the number line, like where's 50% lie? Like just start placing some things you might naturally be able to figure out. Well, that must be a 30. The same idea we've done before. We're going to have here, we're going to have here. And students will keep kind of placing. So I've had students many times go, well, you know what? If I take 100, this is the beautiful part of the number line. This is where the flexibility comes in. I had one student say, if I take 100 and split it up by 10, that should give me 10%. So every 10 increments of 10% should get me back to 100. So if I do that, that makes 10% here. I split it up into 10. If I split 60 up into 10 equal sections as well, then I get 6 per section. So that's just this dividing by 10 right here. We've divided by 10. We've divided by 10. And then now saying every 10% is 6. Okay, and then you could say, well, now I could go up by 10% increments and count by 6s. So what's another 6 added on right here? Well, that'd be 66. So 66. And then what's another 6? Wait, this difference right here is 12. That's 2 6s. So that must mean I've got another 6 here. There's 66. They're counting by just, we're skip counting. We're counting by 6s now. So 66. That would be another 10%. So this must be 110%. And then there's another 6 right there. And so that must be another 10%. And now we have 120% right here. That's what one student in my class had shown on their number line. They say, look, if it increased from 100% up to 72, that difference now, that increase from here to here is an increase of 20%. So we now have an increase of 20%, which is our answer here. Now, the nice thing here, remember the flexibility, is that I've had another student show a different strategy or a different solution using our number line. So I have 0%. I have maybe, let's put 100% back here. And that's 60. And we're trying to figure out 72 again. And another student did this, a very, a similar strategy here to say, look, okay, well, I don't know what percent this is up here, but instead of going to 10%, they went down to 1%. And it's like, how much is 1%? And then they say, well, that must be, I divided this into 100 equal sections. And therefore, this number should be divided into 100 equal sections. So we now 60 divided into 100 equal sections is 0.6. Hey, that's a very fancy number right there. We have 0.6. All right. And then I say, well, I needed to figure out, well, how many times does this go into this? That's how much percent we have here. And that's what this student did, was like, I need to figure out how many times. So they took 72 and divided it by 0.6. And that told them how many times. Hey, guess how many times? 72 divided by 0.6 is 120. And so we said, hey, that must be 120 times. That's 120% right here along the number line. Very nicely done. Very flexible strategy to think about how we can increase our percentages and work with top of that number line and the bottom of that number line, and we can scale in tandem, which is amazing to see. I'll do one more from this challenge set. We could say a number went into this machine and it increased by 20% and 36 came out. And we know that a number went in. I don't know my 100% this time, right? So here's my 100%. I don't know what went in, but I know that 36 came out and it increased by 20%. So now I have 120% here. It increased by 20%, and that's 36. And so we're trying to figure this number out on the number line here. So notice we've had students say, okay, well now I've got to think about how to do this. Well, I could break this up. This is what happened in my class. They said, you know what? I'm going to divide that by 10. If I divide that by 10, that brings me down to 12%. And if I divide that by 10, I get 3.6. And then, well, that helped me out, but maybe I could divide that by 12. And if I divide that by 12, that brings me, because I know that 12 goes in there 100 times, or sorry, 10 times. And so then they said, okay, well, if I divide that by 12, I get 10%, which is right here, 10%. So now I have to divide 36 by 12 to keep that scaling in tandem. I'm going to scale down here by 12. And so I divide 36 by 12 and I get 3. So this, now I've got this nice pegged number that every 10% is 3. And so now I want to go from 10% to 100%. Well, I know that because we've been very flexible with our number line and working along the number line, there's going to be 10 of those there. And now I have 10 of those here. I'm going to scale up by 10 and I get 30. So it must have been a 30 increased by 6. And you can even see it right here. Look at how much does it go up by here? Hey, that's an up by 6. But look, I could go up by another 33 is in here because I go up by 3 is every 10%. So there's 110% right in there. And you can verify, hey, this works. This is a really nice confirmation that if every time I go up 3, I go up 10%. And I can scale, again, in tandem along my number line. And notice, just because we were using the number line as a model, there is really no teaching of how to do this particular problem. Because my old self would have said, you know, I got to work backwards now. So I'm going to set up this and I'm going to do this. And oh, this problem's different because now we have an unknown in this place. If you use the double number line to solve any of these problems, it's the model itself that helps you build that fluency. And as long as we continue to practice it, it can help build kids' fluency. So I wanted to show you the model that you can use to model any sort of percent problem to use. And then now what you can do is, once you're comfortable with the model, then you can be starting to teach through problem-based lessons. Give your students some problems to solve. Like these problems right here in this Desmos activity are really great for number talks at the beginning of class. So you could pose 1 or 2 or 3, and as you jump around, you can see that there are a couple more that you could be doing. And again, if you're using the number line to help model this, it can be very nice for your students to be flexible along that number line. Now I'm going to show you a lesson that I use regularly with my students when I teach percent, and I've written about this on my website, mrorr-IsAGeek.com. And I just want to kind of walk through the slides and then show you examples of what my students have done using the double number lines. And sometimes they don't think they're actually using a double number line sometimes when they're solving this particular problem, which is really nice to start with. So there's a problem-based lesson that gets kids active and thinking before you've done any sort of strategy building or consolidation. Ask my students to go to the boards with the neighbors and draw a tree that is 20 units tall. And so they get trees, and once they've done that, right away I ask them to draw one that's less than 50%. We're thinking about those pegged values right away. So you get students who draw a tree that's 20 units tall, like in this picture, and then one that's 50% or less than 50%. So they have to immediately start thinking, where is 50% along the number line? And what height is that? That's that peg number, but I didn't ask them about that specifically to develop the strategy. But this problem helps develop that strategy in that model. Then we ask them to draw one that's 50% more. And so how do we know it's 50% more of the original height? And then here's the beauty one. Let's draw one that's exactly 30% of that original tree's height. And this is where you want to watch and listen to students' strategies, because this is where you're going to start to see how they develop that fluency along the number line. And again, the tree, if I just tip the number line up, I now have a vertical number line, and it's what's happening here. So students, in this particular one, students had said, you know what, 50% is 10 because it was 20 years tall. And then they said, you know what, if I need it to be 30%, well, I know that if I take my 50% and split it up into 10 units, I get like 10 sections because that's how long it is. Then I get 5% per section. So that's like I've got this 5% for every 10 unit long section, which is really nice. And then or a unit section. And then I look, in order to get 30, I need 6 of those 5%ers. And then that's how tall my tree is. It's 6. And so there's that flexibility along that number line to make that happen. So then we said, you go, well, why don't you make one that's 85% of the original height? And so we can now go, hey, well, we know that 5% is every increment. We can count by fives. How about 62%? And so we can start to see, well, we can use our number line to start looking at scaling in tandem and multiples along that number line. And you can see that that's similar to this strategy over here. It can get kids to be very specific with the number line and what they're going to do in this problem. You can see it grow, and you can get kids to purposely practice during this problem without, say, giving them a worksheet. Here's another example of how powerful the number line can be. We were looking this week with my ninth grade students on investments and simple interest versus compound interest. And we started with just a simple interest problem, but I wanted to get them thinking about how, building off our understanding and fluency already of percent, into getting into that application of percentages. And so starting with simple interest first, we just said, you know what, an investment grows at 6%. How much did it grow in that first year or in that year? And then we said, let's say we took that interest out and it would grow every year. How much would it grow in 10 years or in 20 years? I want to show, what some of my students have done and what you can expect to see if you did a similar problem with your students, if you've been working towards fluency as a method of making sure that that's part of your class is something I actually talk about with my students. Is we want to be fluent, and in order to do that, we need to solve many problems. If you want to look here, this is what one of the groups of students did for this particular problem. Is you can see the number line across the top here is that they looked at those pegged numbers. This particular group went to 10% right away. To say, look, if 100% is 350, 10% was 35, and then you can see them, this counting up strategy. They counted by 35s every 10% to get to where they wanted to go here. And they're saying, look, I can fill that number line out, but you can see that they also, they were like, I got to get down to 6%. So 6% is somewhere in here. And so they thought initially about 1%. So right up here in the top corner of this image, you can see, I'll try to zoom in right up there. You can see them thinking about, I'm going to take 35, which is 10%, and I'm going to split it up into the 10 increments. And what did they get? They get the 1%. And when they got 1%, they got 3.5 for 1%. And then they said, you know what? I need 6 of those because I want to grow up by 6%. And that's where they came up with their 21. And then you can see them grow that 21 every year. There's my simple interest, right? We're growing by a constant amount. That's what one group did. Here's another group did a similar strategy, but they had already started to work towards a multiplier of realizing that 6% was a multiplier, and they got that 21 right away, and then they started to show that change in the table. And that's because a group had worked towards thinking about a multiplier along the number line and started to see a connection between the multiplying strategy with the additive strategy. Here's another group that did that same type of strategy. They grew it by 1.06%. They had already made that multiplier connection. Here's another group that used the double number or the number line to help there. You can see this one was very interesting. When I talked to this student, this group of students, the student did the same type of thing that other group did by the pegged values, and they said, hey, 10% is 35. But they thought about the problem differently, knowing that if we're going to go for 10 years, they said, you know what, if it's growing at 10 years at 6%, and we'd talked about it, they had already kind of known that the interest would come out. So every 6% was the same. They said, well, 6% for 10 years is 60% growth. And so you can see that on the number line. They went from 10% to 60%. And they said, you know what? It's going to grow by $210 at the end of 10 years. So that was really nice to see as well. You can see that fluency, that flexibility along the number line to help get there. You can also see them right here. Their 1%, their 6% was at 21 bucks right there. So some more examples for you to have a peek at on, and hopefully I've convinced you that a number line is a really nice strategy to show your students. And in particular, I want to point out one that's really nice is Niagara Falls. Now, Niagara Falls is a unit, a 5-day unit on division, but eventually gets into percent and working with percent. So if you start on day 1, you start with division, but on day 3 is when we start getting into percents, and you can see that we've got a problem here that asks them to figure out what 40% of a value is. And we walk through what some students might do on that problem. You can see the double number line exist as a model to help solve problems here. That can be a really nice task to get students to start to show that model. And that's a really important point about using models and tasks is, how do I choose a task that helps elicit the model? The model is really important. And the task selection can also be really important so that a model will come out that helps students be flexible. So if you are looking for some tasks, head on over to makemathmoments.com/tasks. Check out this. The link is below if you just want to click over there to get over there. That's a great starting point. So important to build fluency and flexibility into your students, because that's when they're going to become resilient. That's when they're going to become less reliant on you and going, how do I use the percent button on my calculator? They don't have to ask that anymore because you've given them a tool that they can use in lots of different areas. So looking forward to seeing you in the next video, and we'll check back soon. Take care.